Hello everyone, this is Ashwini from Sri Venkateshwara College of Engineering, affiliated to VTU. Today's topic is about structures, union, stacks, queues and linked list. So first of all, we'll move on to what is structures and unions. Structures in C is the user-defined data type that is available in C and that allows for the combining of data items of the different kinds. Structures are used to represent to record. Defining a structures. To define a structure, you must use struct statement. The struct statement defines a new data type which is more than equal to one member. The format of the structure statement is as follows. So this is the example of structure's name, that is member definition and member definition. So next, we'll see what is union. Union is nothing but it is a special type of data types that allows for storing the different data types in same memory location. You can define the union with many members, but only one member can contain values of any type. So how do you define union? To define a union, you must use union statement in the same way as you did while defining the structure. The union statement defines the new data type which is more than one member for the program. The format of union statement is as follows. This is same as structure. So this is the example of union. So next, we'll see what is stack. Stacks are nothing but it is a linear data structures that follows a particular order in which the operations are performed. The order may be LIFO, that is last in first out, or FILO, first in last out. LIFO implies that the element that are inserted last comes out first, and FILO implies the element that is inserted first and comes out last. So what are the different types of stacks, operations? We'll see that is as push and pop. So first we'll see what is push. It stacks up a new item. That is, it adds up a new item which overflows circumstances when the stack is completely full. So this is the algorithm for push, and we can take an example. First algorithm is begin in stack is full, return, end, else, incrementation, stack top, assign value, end, else, and end procedure. So next we'll see what is pop. Pop operation is nothing but it takes sometimes out of stack. It is the opposite sequence from which they are pushed and things are popped. The condition is referred to as an underflow in the stack is empty. So this is the algorithm. This is same as the push which we saw, that is begin if stack is empty, return, end if, else store value of the stack, decrement top, return value, end else, and end procedure. So this is the algorithm for push and pop and the operations of stack. Next we'll be moving on to queues. Like first, we'll see what are queues. Queues is nothing but it is a linear data structure that is open in both ends and the operations are performed in first in first out order. So we define a queue to be list in which all the additions to the list are made at one end and deletions from the list are made at other end. The elements which first pushed into the order is the deletion operations and first performed on it. We'll see what is FIFO principles in use. It is like a line waiting for purchase tickets where the first person of the line is the first person served. Positions of the entry queue is ready to be served as the first entry will be removed from the queue and called as front of the queues. So similarly, the positions of this entry queue is that one of the most recent added is called as rear of the queue. So this is the example given below. So next we'll be moving on to insertion and deletion in queues. So what is insertion? Insertion is nothing but adding an element to the element, the rear of the queue. Deletion is removing an element from the front of the queue. So here insertion is used to insert an element into the queue to add the rear of the queue if queue is empty. The new element becomes both the front and rear of the queue. If the queue is not empty, that means new element is added after the current element. So deletion is to remove an element from the queue, as we all know that. So you remove the front element of the queue. If queue becomes empty after the deletion or front of the next element of the queue. So next we'll be moving on to the examples of insertion and deletions. That is nothing but insertion as the NQ5, Q will be 5. If NQ is 10, Q will be 5 and 10. If NQ is 15, it will be 5, 10 and 15. These are getting added. Deletion is nothing but remove the elements from the front of the queue. That is, remove 5, Q will be 10, 15. Remove 10, Q will be 15. Remove 15, Q will be the empty. So this is the deletion operations. So next we will see what is linked list. A linked list is nothing but a linear data structures which looks like a chain of nodes whereas the nodes of different elements. Unlike arrays, linked list elements are not stored at contiguous location. It is basically the chains of nodes which contains information such as data and a pointer to the next node in the chain. In the linked list, there is a head pointer which points the first element of the linked list, and the list is empty, then it simply points to the null or nothing. Insertion at the beginning. Insert an element at the beginning of the linked list. This involves creating a new node, setting its data, and updating its pointer to make the new head of the list. At end and middle. In the deletion, you can see same as the insertion at beginning, at end, and in the middle. So these are the examples of linked list, that is insertion and after deletion. That's all for the video. Please do like, share it to your friends and families. Thank you.